Okay, let's get back to our programming, and specifically programming control, controlling the flow of your program. So, first thing that we learned how to do in the last week is figure out how to compare things. That's what relational operators are. I need to kind of express questions to my computer. Is this bigger than that? Is this equal to the other thing? And so forth. And for that, the result of such an operator is typically a logical data point, which is false or true, 0 or 1. It can be expressed in different ways. Here we're calling it logical, and again, it's false, capitalized, and true. And if something is true, it's a literally if-else, just like it is in the language. So if something is true, then we can say, hey, basically, if some expression is true, execute a block of statements. Okay? So here, if x is larger than or equal to y, don't forget the colon. If you do forget, your Python will yell at you, but on the test you need to remember to put it in because you'll be writing it. And then here there's only one statement, but there could be a block. Okay? Whether or not this is I tend to put in this at the end of the statement. It doesn't matter. It matters only if you want to pile up multiple statements in one line. And then else if, which short of it is elif, then you can check another expression whether it's true or false. And again, don't forget this colon, and then a block of statements that you would like to execute. Here, indentation is really important because that's how Python recognizes the block of statements that you want executed only if some of these expressions are true. If not, and if it's indented with the main code, it's going to be executed with the main code. So you have to be the decider. Python is not going to check your logic. It's just going to check whether your syntax is all right. Okay? And as long as it understands, it's going to execute. And that execution might not necessarily be a good one. All right. So we could have also else, which is sort of a catch-all for if everything else above has failed, well, please warn me, print something, do something so that I can proceed. Again, you're a designer of how to use this construct. Okay? So one thing that I'd like you to now do as a quick exercise to review this is, actually this is a solution. So input the number from the keyboard and then determine whether that number is even or odd, and then say something. Input is a command we use. Okay? So this is also apparently a review of our previous lecture. So everything is now just piling up, so I do expect you to, if you don't remember precisely, then know where to go to actually find it. And on the test, I'm going to ask you to remember precisely. And just a math reminder is that you need to check when you divide the number by 2, this integer, whether you have a leftover 1 or 0. There it is.
Huh? You want us to do something like this?
Yes, but I want you to determine whether the number is even or not, odd. So you need to input the number and then check, and then use if-else structure to inform us what is going on. Key elements are input, then there's mathematical operation of the finding a reminder, then dividing by 2, and you check whether something is equal to or not. This is relational operator for equal, and use if-else. And then to inform something else, you need to use print. And then start programming. Is your Python notebook yelling at you yet?
Yes.
Yes, of course. That's its job. So let me relieve you of your pain. So input, you can say any message you want, enter an integer or whatever it is. Then you have to remember that what you input is a string, so you have to convert it. That was probably the biggest thing. So you convert it to an integer. You just say integer of a. And then there's this modulo, or reminder bit while dividing by 2. If it's 1, this number is odd. Otherwise, it's even. And then you can test it.
Does there have to be a semicolon after each?
No. Again, as I said at the beginning of the class, I typically put it in because that's my habit from programming elsewhere.
From MATLAB, right?
In C, you have to put it. In MATLAB, it's optional. If you don't put it, then it's going to print everything as you go. Like it's going to just dump everything on the screen. And if you want to prevent that, then you have to put it in. So by default, because of those two, I put it in. It doesn't matter. One could argue it's actually cleaner code without it, but A,
The percentage.
it's a reminder, the division. So integer division. So 5, it's called modulo. 5 modulo 2 is 1 because the letter U. 5 is equal to 2 times 2 plus 1. So that reminder is 1. And if I'm dividing by 2, my reminders, the only reminders I could have are 0 and 1. Right?
Is that a percent sign division?
It's modulo. It's reminder during the division.
Reminder during
Reminder during the division. You're like 2 minutes out of phase of the
reminder
previous
during the
question.
division. Got it.
Yeah. So integer division, right?
The remainder due to
Remainder.
remainder.
Yes? Did everybody get it right?
I hope so. That's the answer.
All right.
Else?
Well, it is in your slides, so you can refer to this. But I would like to also, at this point, kind of comment on your mental processing of a task. Okay? So it is very useful. So typically you divide whatever it is that you're supposed to program into little tasks. Input this, check whether this is true, things like those. So you divide it. And then spend a couple of minutes, and that can be done with a piece of paper or just any kind of open up a document and kind of write notes about what do you think goes inside or what it is that you need to look up. Just plan mentally what you need to execute. And sometimes you'll be stuck on number 2, but you know how to do number 3 or something like that. Kind of leave yourself a note in the code and proceed as if you've done the middle point and try to attack what you know. And that will kind of pull you in and pull you forward. Okay? And try to, whatever you put in, try to quickly test it. So here, this part, printing the type, is really just testing how things work. It's like remembering vaguely though, oh, it inputs a string, and what do I do now? And maybe you don't know what do you do now. You can leave yourself a note, address this later, and move on by typing in number on your own, right? You can test this part simply by typing in some number AI equals to 11, right? Without inputting it from the keyboard. So you can always isolate pieces. Think about this as a machine that you're isolating part by part, right? And work on the parts that you know how to do first, and then move on. Does that make sense? So don't get staring at the blank screen and paralyzed. Okay? Work on something you know in there. Work on that first. And that will pull you in and you will start solving the problem. Okay, so now we're going to go to loops. And loops are basically there for repetition. That's what computers are great about, repeating something 1,000 times, 100,000 times, however many times we need. And we have 2 basic structures to do loops. Okay? First one is a for loop, where you basically have a counter or an index that is tracking your progress. Okay? And that index can come in various forms. Okay? And basically, as that counter keeps going, over a certain range of values, you will execute an entire block of statements. And that block of statements can actually depend on the index itself and change how it works based on that index. And another one is possibly you have something a little more complex going on. You're constantly recomputing something. And you want to check that value, whether it's above or below a certain threshold or something like that, and you want to keep going until something is true about it. And that we do, say, while. So while some expression is true, you keep going, otherwise it'll stop. And again, this block of statements can actually update this value constantly. So let's actually do a little bit of practice. First thing that we're going to do is figure out how to give ourselves a range of value, this counter, this index that is going to track us as we go, how to basically do something about it. So let's actually do, I'm going to start typing in. So the simplest structure part, so this is for loops. I'm continuing in my 3.1. You can do whatever you want to do as long as you know where you saved it. So let's actually just do A, and there's a range function. And let's say that I just say range from 1 to 5. And then print yourself that A. So this range function gives me actually a list of values, integer values. And that's good for counting. We count with integers really well. Okay? So when I, oops. So somehow it doesn't want to. And then I'm going to say for my index, I'm going to call index I for short. For this index in the range, and there's this magical column that always needs to be there. And then my block of statements will be now really simple. I'm just going to print it just to see what it is. Let's see. So basically, I can see that for I in this list, I'm going to print I as I go. So first time I execute, my I is the first value in this list, which is 1, and I'm just going to print it. And then 2, and then 3, and then 4. And even though I said range 1 to 5, it stopped short of 5 because that's what Python is doing. It never includes that last value. Dang it. Okay? I don't like that habit, but that's what it is. So let's just play with different ranges. So now you can just, there are different ways you can actually do this. So I'm going to actually copy all of this into a new one. So let's actually just, I can actually omit the first part. So if I just give it one value, it's going to understand it as an endpoint. And it's going to start from 0 because Python always starts from 0. So if I don't give it 2 values, it's going to understand, okay, it starts from 0 and whatever you give me is the last one. But only up to the last one and not the last one. So 0, 1, 2, 3, 4 is my range of 5. Then I'm going to copy it again. I can actually step every 2. And then I'm just going to, so I have a spacing 2 in between them. I can step every 3, I can step every 30, so forth. If I step every 30 here, my only number in the range will be 1, and then I'll be out of the range. So again, Python will do it. It's not going to check your logic. Your list could be empty, in which case it's not going to do anything. Okay. Let's actually just quickly put in and just test what it does. So did everybody have a chance to catch up? So you can do range from 1 to 5. It's simply a function that returns a list of integers. And right now we're just printing them to see what they are. You can just say range of 5, in which case it's going to start from 0 and stop short of 5. You can step every 2. Let's put in something that doesn't make sense, like what is it going to do? Let's say that I don't know and I want to test. Is it going to yell at me? It's not going to yell at me. It's just going to do nothing. Because such a range doesn't exist. Between 10, starting with 10, ending at 5, and stepping every +2, that doesn't work. So it's just going to do an empty one, and it's nothing executes, nothing got printed, so oh well.
So range, whenever we define a range, it has to be from a lower number to a higher
Yes,
number?
otherwise it's going to...
Okay, so only one direction.
However, let's try something else. Actually, I'm going to copy again the same thing. Let's put -2. Does that work? That actually does make sense. So it's going to start from 10 and step -2. Okay? So just note here, this is an empty range. This is So nothing happens. So this pretty much, if you're just counting your loops 1, 2, 3, 4, 5, and so forth, this just works. That said, for loop in general can do anything or use anything. If I want to use real numbers, so did everybody catch up with this before I move on? So I can have range from 10 to 5. If I step every 2, nothing will happen because that's an empty range. But if I step with minus 2, it's great. I'm just going to count downward. I can actually name real numbers or have real numbers. So I can have, but then I have to use my, I got to import probably. I don't know when I executed this last or if I did anything in between. I'm just going to, just in case, import my NumPy. And then I'm going to say A is NP arrange. It's like one of those subtle things. Well, possibly you want to go from 0 to 0.5 and stepping every 0.1 because that's what's important for you in whatever application you like. You can do that, but you need arrange, not range. Range works with integers. You can print that list. Yeah? So this is actually not a list anymore. It's now a NumPy array, but for loop works just fine. Okay. What happened here? We're going to learn in next lesson. There's a finite space for real numbers in computer memory, for any numbers really. And sometimes certain errors like rounding off and chopping off numbers happen. And that's what happened here. Even though in our world, 0.2 plus 0.1 should be a clean operation and there should be no rounding. Computer is working with binary numbers, not with our decimal system. So in that conversion, things can happen. Okay? So there's certain numerical error that is there because of the finite space that we have to store numbers, and that's actually evident here. I wouldn't be terribly alarmed at this point, but it can sometimes cause small errors. All right, so now basically we know technically there's one more thing that I could do. I could do any collection. So I'm going to now name this list of numbers. Could be anything. Hello, there, 1, 2, 3. So these lists, as opposed to NP arrays, can be collection of everything and anything. Doesn't really care. And I can use this collection as my counter for my loops if I'd like to. Whoops, look at me, print A, print I. Still gonna print it. Does this make sense? It doesn't, but it doesn't matter. Again, computer is not checking my logic. There might be cases where it actually makes sense to put strings and numbers together into some counter for your for loop. But maybe your collection is, fruit, apples, oranges, and so forth, and you might want to have that as your counter without numbering them, right?
What would we use the collection for? What would we use?
Again, like if you have something that actually is by name, let's not use apples and oranges, let's use shale formations in the United States. So let's say that you had a collection called Eagle Ford, Woodford, Mancos, and so forth. You could actually do something for that. Okay, so let's do this. Let's hello there. I'm just gonna call it A again. I'm gonna stop at 3. There's only 3 shale formations in the United States now. So maybe you wanted something to happen, something to get executed based on every formation, and you don't want to be busy counting them, how many there are, so that you have integer counter. You can use the collection like this to do it. Okay. If you were working with people and you have customers and you have their last names and you want to send an email to each and every one of them, okay, then you would go by the collection of names, for instance, and say, then here there would be like, dear so-and-so. You can email from Python, by the way. There's a way to automate everything. How do you think you get all of these emails, spam emails? They're automation at its best, right? So they just take a list of some numbers that they got, or some emails that they put together, and you do that automation of the list, and then you go by names rather than numbers. Okay. All right, so now I know how to set counters. Now actually let's do our first exercise. And that is going to be a simple one. So I'm going to actually type it in so you can have it. So exercise is create an array of 50 random numbers and calculate product and sum of all of them. This is a typical task for a for loop. I don't want to do it by hand. I imported NumPy already, but I'm just gonna re-import so this can be a standalone cell. How do I create a random array?
np.array.
np.random.rand.
How do we want to call this array? A again? Sure. A is, everything is A today. np.random.rand, and I want 50 in there, so I'm just going to say 50 and 1. These are random numbers between 0 and 1. If I wanted to scale them, I can. If I want them to go from 1 through 5, I would start with 1 here, and then do the difference between 5 and 1 of my range times this number between 0 and 1. So then this kind of stretches my 0, 1 range to the difference between the two, and I give myself a starting point. Okay? So I just say in 1, 5 apparently. I just adjusted my task. Great, so I have the numbers. This is now, if you want to verify as you go step by step, let's just quickly print them to see that we got them right. It appears we're okay. I created 50 and 1. Maybe 1 and 50 is more Python-like. Everything in one row. But either way, for this problem, it works. If I put just 50, would it create 50 by 50 or 50? Do we remember? If you don't remember, let's test. It's still 50 by 1. So you can go 150, 50, 150. For this application, it all works, as long as I have 50 of them. Great. So now I have the array. I can turn off my print statement. Ultimate debugging statement is just print everything as you go. And now I want to go through this array, okay, and sum things up, okay, or I want to do a product of all of things. Okay. So I can work with this array as a counter, but I want to produce two things. One is sum and one is product. Those two things, whatever it is that you want to calculate, you typically have to initialize. Give it a starting point. Because computer doesn't know. If you have a starting point in your brain, I gotta translate it to the computer. Okay? So for a sum, our starting point is always a 0. Okay? So S is 0. And I'm gonna say this is initialize the sum. And product I'm going to call P. Products we initialize with 1, right? Because we're going to keep multiplying. And now I'm going to do a for loop. So what am I mentally going to do? I'm going to step through every element of this array, all 50 of them, using for loop. And for sum, I'm going to add it to the sum. And for product, I'm going to multiply the product with it. And by the end of the loop, I should be done. Now, I can step through in two different ways. I can create myself a range of indices that go from 1 to 50, or from 0 to 50, rather, for this array. And I'm going to do it twice, so you can actually choose what you want to do. So I can actually do my index counter. So this is just counting how many, right? And now in my block statement, every time I step into the for loop, my I will change, right, as I go. So I is equal to 0. I want to add the 0th element of A to my sum. Okay? So I'm going to increment my sum, or maybe increase, maybe decrease, depending what A is, but in this case it's positive. So it's A of I. And my product, I'm going to multiply. Oh, not P, A. This is my S will be, so here I'm going to take the current value of S, add the new value, and the result of that operation will overwrite S. Okay? So watch out, you are overwriting. And same for the product. You're going to overwrite old value. This is old value of P, or current one. That is, it's going to go to the memory, grab it. It's going to change it and put it back. So this equal sign puts it back. So the way, when you do assignment, the way it operates is first it checks out on the right-hand side what it is that it needs to update the left-hand side with, and then it does it. This is actually it. So we can just now step out of the loop. So don't print. If I print within the loop, then I'm going to print every time. I want to print only at the end. So step out of the loop, remove that indent, and print sum is and S and product is B. You can write down whatever you want to write down. Is this going to work with commas, or do I need pluses, or can I use either? Or pluses? Let's do pluses. Let's see what happens. We can fix it.
It doesn't like P equals P times A. Never mind.
So if you use comma, you can directly print it out, and if you use plus, you have to transfer the S and P into string.
Ningyu is ahead of me, but I wanted students to do that, Ningyu. So if I use comma, it's gonna work here, but there's nothing wrong in trying it out and finding that. So did everybody get what Ningyu said? So for plus, I would have to convert it to a string, essentially. With commas, I can just pile up different things. And it's going to figure out how to print each of them separately. So it's going to figure out how to print this, 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 that. But the reason why plus doesn't work is that it's trying to make that plus operation with different objects, and that's where it's getting stuck. Well, so these are random numbers, so hopefully this is right. I'm not going to do 50 by hand and check, but I could use a calculator and do 3, right, and check, or create some numbers that I can do things mentally. That's up to you. There's another way to do this, and let's see that it does. So this is just an alternative way that I think should work. Let's test it. Essentially, I could use the array itself as a counter, right? So I can count with it. In which case, I need to repeat the initial. I'm just going to copy this and modify. So if I was using for A in this A, then I wouldn't add A of I would actually add this counter itself. And I'm going to actually give it a slightly different name so that it's not terribly confusing. So in first one, I'm actually using an integer counter to count things. In the second one, I'm using array itself. It's technically fine either way. It matters. It's your style or what you find. And I'm getting precisely the same result. Why did the result ever so slightly change here? Random number generator will execute slightly differently. Is everybody getting the subtle difference between the two? Both work. So in the first one, I know I have 50 numbers. I created a range that will loop over them. And range of 50 is 0, 1, 2, 3, all the way to 49, which is precisely how I'm counting elements of an array in NP arrays. Yes? So for each element, I would go through A of I, for this I being 0, 1, 2, 3, and all the way to 49. Yes? So then for this I, or index in this range, every time I step into the loop, I update my sum, I add A of I to it, and I update my product, I multiply A of I times the current product, and that product will keep changing. By the time I'm out of the loop, all of it should be done. An alternative way is to do the same initialization and then just use the array itself as a counter. So for every element of the array, just add that element to the sum or multiply product with that element. Both of these work. The one that kind of sticks to you better, that's the one that you adopt and use. Okay?
In my case, only the second one worked. The first one, it gave me the error that.
So you typed in a little error in there that you're going to find out by the end of the class. This sort of is the key way to use for loops. For your next homework, you're going to get a whole bunch of sums to compute and products that are specified in all kind of weird mathematical ways. That's just for you to practice this, okay? Ultimately, sums that make sense, okay, will be something in your application. Okay? If I go over the well and I want to find an average porosity of that well, I'm going to have to sum up all of the porosities that I have, possibly 3,000 or 5,000 of them, and then divide by the number of them, right? But the sums that you're going to get in your homework will be sort of like just mathy kind of products, so that you can practice the mechanics of writing for loops. And once you adopt that mechanics, you can apply it to anything that actually makes a little more sense. Okay? And the reason we do that way is that it's easier to kind of separate the mechanics first, figure that out, figure out how to ride a bike, then go on a ride that is 10 miles long to see some sights. Right? Because on the real bike ride, first you do that in a parking lot. Real bike ride, you gotta also figure out the traffic and where you're actually going, right? So there are 2 steps. So you're gonna get a whole bunch of mathy looking sums and products to compute, because that just practices the mechanics of doing the for loop. We can also nest for loops, and basically once we learn how to nest for loops, we've learned everything that there is to know about for loops. So I can actually loop over multi-dimensional arrays. So sometimes counting one thing is just fine, okay? But sometimes my array is 2-dimensional, and if I wanted to go over all of the students in this room and I have their spatial arrangement on my mind, then I have to go row by row, everybody in the row, next row, everybody in the row, next row, everybody in the row, next row, everybody in the row, right? That's going. So I actually have a for loop that goes over rows, and then within every row, I have a for loop going over the columns, okay? So let's actually do a very simple thing. This is something that we've been doing, or NumPy has been doing for us, okay? But basically, how would I, this is an exercise. How would I create, so basically add, create a matrix A of random numbers. And then calculate matrix B that is 2 times A plus, 2 times A plus 1. So this is something that I know that I can already do. I can just type it in. If I use NumPy arrays, it's going to do 2 times A plus 1. But I now want to do it by hand so you understand what computer is actually really doing behind the scenes, because for that we need for loops. Because we need to go over all of the elements of A. So let's just create an A. I'm going to again use np random.rand 4 by 5. And I want to create B, and mathematically this B will be the same dimensions as A. So I'm going to initialize my B with zeros. That's a good practice to tell computer, like, look, allocate this much memory for me. Zeros of 4, 5, so this is just initialize B. Up. Let's test that it's not yelling at me. Yes. For random, I can do 4, 5, but for zeros, I have to put brackets, and that's kind of something that. So let's now do this operation of, I want to basically walk through all of the elements. That's the key point, and then do something with it. In this case, I just want to compute every new element B. But it's these elements of A that are telling me where to go. So I'm going to say, hey, for all I in basically my rows are a range of 4. That means I'm starting with 0. I could have also started here with 0, 4, or just 4, whatever works for you. So right now, let me just print of I first. Print that I first. Okay, so these are my rows, 0, 1, 2, 3. Okay. If I just wanted to print A of I, everybody in that row, I could. So this is how I essentially printed every row of matrix A. But not only that, I actually want to walk down each of these arrays that are rows of A and do something with them. So within my block statement, I'm actually going to include another loop. I'm going to nest a loop for, and I need a new counter to go down that column. And we're going to use J. We've been using I and J in range of 5. And then I need to indent once again. And I can now print I of J. But I don't want to print it. I want to compute with it. What do I want to do? I want to create B of ij as 2 times A of ij plus 1. I'm going to let this sink in or type in for a moment. So if I just tell you a story of what this is, I walked through every element of A, and for every element of A, I computed B that is 2 times that element plus 1. That's a story. How do I tell computer to do that? I have to walk through every row of A using one for loop. That's this first one. So I create myself a range of indices that go over rows. 0 through 3. 0, 1, 2, 3. Then, for every row, so this second loop, 4, is going to be executed for every row. Okay, so every time I change a row, I'm going to execute this all over again. And that's what I want. Okay? Then I'm going to walk down that row for every column J, do something with A of ij. In this case, 2 times A of ij plus 1. That is what multiplying scalar times a matrix plus addition do when I actually just write B equals 2 times A plus 1 in terms of matrices. You can be grateful for NumPy for doing that behind the scenes. Yes? But this is what it's actually doing. And if you have a task on something that hasn't been pre-done by some Python module already, like NumPy, then this is what you need to do. You need to walk over all of your cases, possibly with nested loops, and do it. Okay? All right. I see you on Wednesday.